Hello, I am Xingxing. I am the Assistant Professor of Interaction and Media Design at Parsons.
Hi, I'm Catherine Moriwaki, Associate Professor of Media Design at Parsons.
So today in Critical Computation, we are going to talk about network choreography. It is such a complex topic with many different layers, both technically, theoretically, and performatively. So we're going to go through some of the important aspects of network choreography that both me and Catherine have identified. And hopefully that would help, putting a footing down as a starting point to begin thinking about network. So what is an API? You are going through tutorials to learn how to use an API, but what exactly is an API if you have to describe it to, a family member or a friend who might have no experience with this? So an API stands for a application programming interface. It consists of pre-written commands that allow two different pieces of software to speak to one another. So that is a key. It is two different interfaces that allow communication between two different softwares. When we're using API in a network, web context, we're most likely trying to retrieve some form of data from a server into our own, code. In this case, we're using our P5 editor, therefore porting data from another software into our own software, right? So in order to do this, it is crucial that we use something called an API key. And an API key essentially is a password that gets randomly generated for you by the server so that you can access its database. There are a lot of different kind of conditions that can be set on the API key. For example, the API key could have expiration date. The API key is a way for the server of, like, let's say Twitter to be able to like track and know who has access its database and what kind of data it's pulled from. And so every time your program runs, you'll be making a request to the server to send some kind of data over using your API key. Generally speaking, you would be generating a new API key for every new piece of software that you create. So generally speaking, you're supposed to not use the same API key across different software, right? It should be specific. It should be treated as a password. And you can also cancel or delete the API key when it is no longer in use.
More broadly, one of the things that we wanted to draw attention to is this idea of an OSI 7-layer model. This specifically isn't something that we're going to be working with technically in the course, but it is more of a conceptual model for how the internet and for how telecommunications applications are structured. So this was a model that was created during the late 70s, during a period of intense proliferation of diverse computer networking methods that were oftentimes maybe competing or not necessarily interoperable or compatible. And so it was a way to sort of bring a lot of these technologies together under one conceptual framework. And each of these different layers actually represents a kind of abstraction about how a protocol and how a series of communications between different kinds of devices might be structured in order to be able to facilitate the transfer of data. For example, the internet is an example of a network protocol protocol that is built along, the concept of layers, conceptual layers. And you can see in this diagram over here that you have this abstracted model, the OSI model, and then you have this TCP/IP model, which has been implemented for how the internet is actually structured. And all of the different layers don't completely line up, but what you basically see is a kind of overarching structure and a shared conceptual model, which then helps guide how information is both structured, organized, and then sent and verified by receivers and senders. So without that, without a kind of structured, shared way of formatting data, the kind of network communication that takes place on the internet or between software environments or even electronic devices would not be possible. And so this really gets to the heart of, from the technical end, of networking, network models, ways in which we are then able to exchange and share data. So this has implications for us in the physical world, in in terms of the phenomenon that we experience, either see, hear, uh, I guess in lesser cases, other senses, but specifically in terms of the transmission of audio or video or images over, say, for example, the internet. How those signals are then uh, captured, recorded, and transmitted over networks. And there is a lot to be said, basically, for the kind of information that is lost throughout that process, as well as the way in which the information that is captured is fundamentally changed through that process. So, for example, a lot of people who are enthusiasts about vinyl records or enthusiasts about analog film, right, will oftentimes claim that something was lost in the transition from analog to digital recording methods. And to a certain degree, in terms of the sort of technical components, uh, you know, digital recording is very high fidelity now, digital video, very high fidelity as well. And yet, oftentimes, those enthusiasts are talking about some kind of intangible, qualitative element of the image or sound. And at the same time, the way in which these uh, signals are recorded, transduced, and then processed really truly does actually fundamentally change and alter the medium in terms of how that signal is segmented, how it is broken up into discrete parts, and then maybe transmitted, sent, and received across long distances over network. I think that there are absolutely epistemological questions, really, about what's known, what's not known, and what gets lost in that translation, which is not necessarily something that is either good or bad, but at the same time introduces critical questions about what information is valued and privileged under those kinds of structures and schemes. Here is an example of the encoding differences between, say, for example, WAV file or MP3. And, the signal that you see to the right is an example of the audio signal and how it's recorded, right? Digitally. And you can see with the MP3 that each of those individual steps sort of represents a discrete moment of sampling. And as a result of that, then the signal itself changes as it is, in a sense, modified and captured. And though our own, hearing faculty, ability to be able to discern those differences might not necessarily register in listening to a file. As I said before, enthusiasts and connoisseurs of such things will claim that there's a difference, and at the structure of how the file is actually created, in many ways there actually is a difference.
So now let's take a turn to look at the kind of projects artists and designers and technologists have created using the advantages and particularities of a network infrastructure. So what you're seeing right here is one of the seminal work created in 1983 by Sherry Robinovitz and Kit Galloway, called the Electronic Cafe Network. And what the Electronic Cafe Network is, it's a telecollaborative network connecting informal public multimedia communication venues together. So notice that this was created in 1983, and it's a year before the highly influential novel called 1984, written by George Orwell, where he essentially made a kind of prediction on what the world was going to look like. I mean, a fictional one, obviously, in 1984. And it's a prediction, or it's more so a fictionalization or imaginative fiction that talks about a kind of totalitarian society where people are absolutely scrutinized by complete surveillance. And so this work served actually purposefully as an antidote, meaning a kind of counter narrative on questioning what happens when the artist controls the means of production in a certain way, right? Like if we own our own network and the network is not controlled and owned and monitored by a higher entity, how would that change the way community forms, and how would that change the nature of our communication? So here is basically all the different layers you can see on the image of the different kinds of technologies that they have included and trying to juxtapose next to each other. And one thing that they were interested in, like, remember, this is 1983, there was no Google Translate. So one thing that was fascinating for them was, how could you create cross-cultural, cross-lingual communication without using language translation? So for example, can this juxtaposition of different network and different kind of imageries and videos facilitate a kind of creative conversation between people, even if they didn't speak the same language? So what you see here is actually a example pulled from their archive that is trying to compile almost like a kind of collage of community memory, and specifically of the local Los Angeles communities, and trying to see like who are the communities that's in this city, and what happens, how do they coexist, what are the different ways their coexistence can look like through the mediation of different kinds of technologies. This is a different artwork created even 2 years, or actually 1 year earlier, in 1982 by Robert Adrian, called The World in 24 Hours, actually performed within the frame, the duration of 24 hours, at Ars Electronica in Linz, Austria. What happened was that the artists coordinated with multiple locations across the globe and found a way to send a message that would get sent to multiple nodes across 24 hours. Right? And it's just like thinking about how the world has really shrunk since 1982. Like we don't really have to necessarily think about the kind of labor and the kind of infrastructure that like the submarine network that we talked about in the last lecture is doing for us, right? Like in this case, in this when there was no sort of solid infrastructure to go around the earth before, you have to literally send someone in Japan a fax through a fax machine and get that person to like communicate to someone else through a phone call. And there's just like all these different ways of communication that was not necessarily unified or internationalized, but has its own creative merit, has its own kind of you know exciting frictions. So this piece is very much about that. This is a alternative forms of networking. This project is called Pirate Box, and what it does is that it's an offline wireless network. So even when you are working with wireless networks such as Wi-Fi, you don't necessarily have to be connecting to people outside of this geolocation. So for example, Pirate Box was like oftentimes used as a kind of like mobile library, or as a folder for like a classroom. So you could basically use this to store any kind of files. It's a file system, and essentially like as long as the people are moving within the proximity of its Wi-Fi range, then they can access the files. Otherwise they can't like find the files because it's not actually connected to the internet. So there are many different ways to think about the higher network infrastructure and how you use them, and the kind of communities and politics that's going to emerge based on these like really concrete decisions that one makes on network.
And this is an example here of a mesh network. So Xing was mentioning networks that are hyperlocal or networks that are created for communities. Within New York City, there's an organization called NYC Mesh. And throughout cities around the world, there are communities, intentional communities that are seeking to create their own networks. In this case, with NYC Mesh, it's specifically a mesh network with access to the internet because commercial access to the web is highly centralized, embedded in a basically structure and system of control. Um, and internet access through these fixed sort of infrastructures are always reliant on commercial carriers and providers. A mesh network is a network that relies on multiple different nodes. That rather than having a kind of singular top down hierarchy, are comprised of a range of different network nodes that are that can connect to the internet, and then are able to provide connectivity not through one singular network provider, but through multiple different connection points. And this image that you see right here is an image that details the current coverage from NYC Mesh. Various different individuals, what they do is they decide that they want to become an NYC Mesh node. They then commit to installing the hardware needed to connect to the mesh and open up, in a sense, their hotspots so that they can join this community network. And this is but one example of various different highly local initiatives that look to creating a network that has its own resiliency, that in which the data that is shared over that network is not kind of beholden to the priorities and whims of a corporation, and where the network is really then truly a community resource that quite literally connects community members, But then, in this sort of larger metaphoric sense, brings the community together through telecommunications.
Here is a very specific example called the Red Hook Wi-Fi project that essentially is a really excellent example of how a mesh network can be built with a highly community-centric mindset. So we're going to watch a 3-minute video that takes a look at what Red Hook Wi-Fi does and how they are community-centric.
Red Hook is like a little town. Just about everyone in Red Hook know each other, but we don't really have no hub in which residents of Red Hook and business owners can like communicate with each other. And to me, that made absolutely no sense.
We have a lot of opportunities and events. We're trying to get to the community, and it was hard always to bring the community into our doors. What's a better way to disseminate our information?
With instructions in hand, this team of Red Hook residents installs a rooftop router.
Red Hook Wi-Fi was essentially a way to increase our reach into the neighborhood. Hurricane Sandy came and all of the communication networks got wiped out, but Red Hook Wi-Fi and our nodes stayed up. They had power. Our network became like the central communication source for especially public housing residents in Red Hook for 10, 20 days after the storm. And so because of that, we were able to sort of gain attention and resources.
I went through this program called Digital Stewards Program.
A year-long technology training program of the Red Hook Initiative.
I got a little taste of everything in the technology field.
And then they sort of focus on an area, and then eventually that they build their skills further, and then they go off to an internship and a career.
I come in every morning, I check the network to see if any devices are up, down. We have to look for ways to expand the network, pitching to like businesses and stuff like that.
We're building a free Wi-Fi network for the communities, but the whole thing happens because of digital stewards, community members, staff at RHI. If there is success, it comes from the fact of so many people being part of the work.
I came here expecting just to get work, and it completely like transformed like how I think and like in my path in life.
So this is an excellent example of a community technology approach. And it is all about how do we exit the framework of the top down and think about the framework of the bottom up, right? Like how do we start building a foundation where people in your neighborhood gets involved with building the foundation of the technology that this neighborhood uses. In turns, as a consequence, bring collective experience into the neighborhood, bring collective knowledge that's hyper specific to the needs of the neighborhood, and bring job opportunities and trainings for people who are interested. And so this is the opposite of like using Verizon Wi-Fi and have someone come over to your home and install your internet, right? This is more like, oh, my neighbor over there can help me with this aspect of my internet. and this is a very different kind of relationship when it comes to thinking about data accountability, accountability relating to how technology is built, who has a voice, and who controls it ultimately. So this sort of like lends us on this sort of like one of the final note that we're both eager to share with you, this notion of community technology, which is very much an approach of thinking about how a designer, how an artist or a technologist position oneself when it comes to thinking about how they begin a project, who is it for, and who funds it, and who maintains it as well, right? And community technology offers a very powerful lens when it starts thinking in a hyper local sense, designing with the community, and also have like a broader global mindset when it comes to thinking about the implication of something that you're building, right? But that doesn't mean designing for the global. It means design for local and thinking and considering about global impacts. What you're seeing on the right-hand side, that is another project called EII, actually initiated by the Detroit Community Technology Project, a website that you can also go check out. They're really great, and it's an initiative that addresses the lack of internet access in Detroit through the creation of neighborhood-governed community wireless networks. Since 2015, Detroit has been one of the country's worst connected cities. Instead of waiting for internet from delivered by corporation to arrive into their city, and they decided to take a different approach. They have different ideas for it, right? So what the project is about is creating a world where there's a healthy digital ecosystem that is co-owned and co-decided by the community of Detroit.
This actually really shifts the opportunities to, in a sense, make meaning out of technologies according to the needs of and the interests of people, as opposed to technological structures and relationships of control and power that exert themselves through those technological schemes.
That marks the end of our lecture and also the end of the critical computation series. Congratulations. And we hope that this lecture series has been useful in some ways, and continue to look forward to seeing updates on what you do with the materials or the seeds that might have been sprouted throughout this class.